Hey guys, Mr. Lowry coming at you. I'm going to try something a little bit new today, and hopefully this works out well. I'm actually going to run through like a screen share video and show you some cool things in Desmos, and I want to talk about a little bit about the different forms of quadratics or parabolas. Um, so I'm actually going to be looking this way at my screen because I have my camera here, and then I have my monitor here. So if I'm not looking right at you, that's why I'm actually looking at my screen. Um, but this is a little document that I put together that just goes through in a little bit more detail the four quadratic forms that we've talked about. We've been talking about conic sections, we talked about circles, we talked about parabolas as well. So when we're talking about parabolas, we're talking about quadratics. There's several different forms, as we've discussed in previous videos, which can be a little bit confusing, and the naming conventions sometimes get a little bit messy. And depending on what book you consult or where you're looking on the internet or whatever, some of these terms can be a little bit different. So I did some research and tried to find the most common way of talking about these things, so that hopefully I'm consistent with what you're going to see in the future. But this is subject to change again based on your class. So you're just going to have to kind of go by context, go by with what your current teacher is saying and what the current book that you're using is saying. I know that's a little bit confusing, but these forms are all still valid. What we call them might change, but the forms themselves are very useful. And I want to run through a little bit in detail about what those different forms are. So this document I've shared with you, or by the time I post this video, I will have shared with you so that you can use it as a reference. But these are the four forms that we're talking about. So the first one is standard form. Now, again, we talked about how there's standard form for polynomial functions, and quadratics are degree 2 polynomials. So this is kind of how you would see it if you're talking about polynomials. This is standard form for any polynomial. And we got the A, B, and C and kind of what they stand for and what they do. So what I'm going to do here is I'm going to take this function, or I'm going to rewrite this function in Desmos, our graphing calculator, just so we can kind of mess around with these letters and see what they actually do to the graph. So let's go ahead and switch over to Desmos. And I'm going to show you how to do this. You can do this on your own and you can play around with this. It's actually kind of cool. So what I'm going to do is I'm just going to type my equation. Now we can use f of x or we can use y. I'm going to use y just to make it a little simpler. But I'm going to go ax squared. And you'll notice that right as I start typing, it says, hey, do you want to add a slider for a? What that's going to do is it's going to allow us to change the value of a, so we don't just have to have a fixed value. So we're going to add that in just a second. Let's finish writing our equation here. So I'm going to do plus bx and then plus c. Okay, so I'm going to actually add a slider for all of these. And now you can see here's a parabola. So A is going to be 1, and B is 1, and C is 1. So that's kind of interesting. We got our parabola here. Now we can actually set these to 0 if we wanted to, for B, for example. Set it to B. And C we can set to 0. And right now we just have our standard parabola, right? So if I wanted to kind of like hard code in what this is just x squared, right? Y equals x squared. You can see how those guys are overlapping. Now, the a value here is the number that goes in front of x squared. It's the coefficient. So I could like type a 2 here, right? And I could say, okay, now I have two graphs, right? This black one is 2x squared. But what I could do instead of like doing that multiple times is I can just take this slider and say, let's change the a value to be 2. And now you can see that it's actually matching that. So instead of having to write like all the different types of equations, we just have to write it once. And then we have these sliders that will just change those values, right? So right now, again, this would be 2x squared because b is 0, this would go away, and c is 0, okay? So let's just play around with the a value for just a second and see what that does. If I increase a, what do you notice happens to the graph? Well, it looks like it's getting steeper. It looks like it's getting skinnier. But actually what's happening is it's getting stretched. It's getting taller, right? We're multiplying this. So all the y values are actually getting taller, and that has the effect of making it look skinnier. So this is our vertical stretch factor, right? A is our vertical stretch factor. If I increase A, it's really getting taller and skinnier. Okay, so that's how that affects that. We also talked about before that if A is negative, do you guys remember what happens if A is negative? Parabola opens down, right? Okay. So that's kind of how that A, which is our vertical stretch factor, affects the parabola. Okay, let's talk about C really quick. So let's change this back to 1. A, we'll change it back to 1. Oops. Okay. So that's just our standard parabola again. Now let's change the C value. So that's the number here at the end. If I move this up to 2, that just moves my graph 2 units up. So this guy right here is actually where my y-intercept is. Okay, if I wanted to like write out what this equation was with an a of 1 and a c of 2, it would be y equals x squared, or 1x squared plus 2. So you can see that those match. Okay. All right, let's jump in and let's mess around with the b. So let's make this kind of something there. Okay, so notice that when I changed b, the y-intercept didn't change. It's still 2, right? It just kind of like morphs around that 2. And when you change the b, it kind of changes the location of your vertex. If you remember, the vertex is found by doing opposite b over 2a and then plugging it in. So opposite b over 2a will give you the axis of symmetry, but then when you plug that in, you get the vertex. So that b value kind of affects the position of the axis of symmetry and the vertex. And if you kind of mess around with this, you can see that it actually looks like it's following a parabolic course here as we change it, which is kind of interesting. So we got this kind of, it's almost following like a parabola itself. But notice that the y-intercept stays the same. So it's still at 2. Okay. So let's set the b at, let's say, 3. Okay. And now we can go back and change the y-intercept to, let's say, 3. Okay. So I'm just kind of moving my graph up. I'm shifting it up. That's too high. Okay. There you go. There's 3. All right, so that's the equation in standard form, or what we're going to call it quadratic form, just to kind of distinguish between it. Now, again, you're still going to see this called standard form from time to time, because this is the standard form of how you write a polynomial function, when you're going to see polynomials more in the future. Let's jump back here and then just kind of finish up. So standard form, again, A is the vertical stretch factor, right? B, we notice, affects the position of the axis of symmetry. It doesn't really tell us exactly what those shifts are, but we know that it kind of affects that. And then C, of course, is the y-intercept, right? The other reason why we call this like quadratic form is because when we use the quadratic formula and we want to, plug it in that negative b plus or minus the square root of b squared minus 4ac all over 2a, when we use that, the a, the b, and the c, those come from here, if you remember doing that. So grab those. If it's in quadratic form, it's really easy to use the quadratic formula, which is kind of nice.